In this video I explain you why I don't recommend using ultrasound cleaning for printed circuit boards in electronics. Also, I will show you how to use cleaning bath correctly. Watch this video until the end to find out why ultrasonic can damage your PCB. Ultrasound at 40 kHz works well with special cleaning liquids for removing contaminants from metals. Important, from metals like medical instruments, solder paste stencils, auto parts, any metal parts. Ultrasound's more effective on hard surfaces like metals. The hardness of PCB textile light is significantly lower, making ultrasound much less effective. Much users pour unknown liquids into the bath and don't follow proper temperature, which reduces cleaning efficiency. The recommended temperature for cleaning liquids is 50 degrees of Celsius or 122 degrees of Fahrenheit. In electronic industry, ultrasound cleaning using only for metal stencils from solder paste. Like this video right now, it's very important for me. The cleaning quality improves when liquid movement inside the bath, which can be achieved through bubbling, barbotage. Moving liquids helps wash away any contaminants and flux residues from under microchips, from under any components. If there is no liquid movement, the dirt of any contaminants can still remain under the components. Since liquid does not circulate between BGA balls, the residues will stay between them. Once dried, there is a high risk of white residues forming on the conductors and BGA balls and create current leakage. I have small list with cleaning liquids for cleaning bath. Vigan US, Vigan A250, Vigan FA+, Surclean 2500, Chemtronic ES132, Aquinox or Ionox. Of course, there are many more cleaning liquids on marketplaces, but they must be water-based. What kind of water, distilled or deionized, you can use for cleaning? The answer is you can use any water, deionized or distilled water, because very important in water only resistance. Distilled water is obtained through primary distillation in distiller. Deionized water is purified by passing through anion or cation filters, activating carbon filters, mechanical filters. Right now about rinsing. Always rinse your PCB board after cleaning in first bath. You need to rinse in second bath. Fill it by distilled water or deionized water. Rinse water temperature 50 degrees of Celsius or 122 degrees of Fahrenheit. You need to monitor water conductivity with TDS meter and replace old water if readings exceed 1 or 2 microsiemens per centimeter. Of course, sometimes you also need to replace old cleaning liquids in first bath. A household TDS meter showing 0 microsiemens per centimeter for real distillated water but doesn't display decimal values. To measure correctly, your conductivity meter must have 2 or 3 digits after 0. Distilled water has a conductivity around 18 megaohms per centimeter, which equals 0.056 microsiemens per centimeter. Water should be replaced when it reaches 5 megaohms, which equals 0.2 microsiemens per centimeter. Since real distilled water is expensive and precise TDS meter is expensive, you can replace water when it reaches 1 or 2 microsiemens per centimeter. It's okay. The best option is to measure directly in megaohms, but you will need to invest in laboratory conductivity meter. Right now about drying PCB. After rinsing, the PCB board must be dried at 60 degrees of Celsius or 140 degrees of Fahrenheit for 1 hour. This is important for removing residual water from under components, from under connectors, from under microcircuits. Right now I want to tell you about key disadvantages of ultrasonic PCB cleaning. Ultrasonic vibration can damage high sensitivity components soldered onto the PCB. Sensors, MEMS devices, accelerometers, frequency generators, gyroscopes, some types of microphones. Ultrasonic vibration can cause damage to any components, wasting time and money for repairs. Ultrasonic does not provide any advantages in electronic cleaning but carries high risk of damages. Right now I want to show you the best way to use ultrasonic bath. For demonstration I bought ultrasonic bath, 2 bottles of deionized water or distilled water, household TDS meter like this, air compressor, 2 air stone bars for aquarium and 2 PCB board. This setup is not for first cleaning bath with the cleaning liquid, but for the second bath, use it for rinsing. First step, I place the airstone bars inside the bath and connect them to standard aquarium compressor. Second step, I fill the bath with distilled water. Ensure that the PCB can be fully submerged vertically in the bath. Place PCB board to the basket vertically. It's very important, vertically. And right now I need to measure water resistance. It should be 0 microsiemens per centimeter for distilled or deionized water. Let's go. Turn on the bath. Do not turn on ultrasound. We don't need it.
2 hours later.
Okay, I waited until the water heated up to 50 degrees of the Celsius or 122 degrees of Fahrenheit. Lower the basket into the bath. Yep. Do not turn on the ultrasound. Turn on air compressor. Great, time 10 minutes. After rinsing, let the water drain into the bath. And third step will be drying in the oven. Like this video, it's very important for me. Subscribe to my YouTube channel. In the description of this video you can find links to my Instagram, to my website with soldering fluxes